Well, today's a bit of an interesting day. We've had a bit of a wander down memory lane. There's my radio technician certificate. I started work in early February 1978. By the end of 1979 I'd achieved my radio technician certificate. By the end of 1980 I'd achieved my supplementary radio technician certificate. Then I did New Zealand Certificate in Engineering, Telecommunications. I completed that in 1983. In 1989 I achieved my Engineering Associates Registration Board certification. So I guess I'm just a bit of an old fart. Anyway, unfortunately this Engineering Associates registration qualification doesn't have much value any longer. Telecom in the early 2000s eliminated any form of financial compensation or recognition of this Engineering Associates qualification. They did that once they put us all on individual contracts. We may actually resign from registration as an engineering associate. I've never come across a company, or let's put it this way, I have not worked for a company since that either recognised it or offered any form of financial compensation or indeed any recognition of that particular qualification. And considering I'm about 3 years from retirement, it's pretty much pointless. And considering I'm such an old fart, we'll talk about this instrument. This thing's a Marconi TF893A. It's actually an audio power meter, and it's quite an interesting instrument in that its input, and the input terminals are up here, just give you a look at them, probably can't see them on camera, is actually a transformer. The input is actually, there's an earth terminal, a center tapped transformer terminal and input terminals. The entire instrument is resistive, so the multiplier and the impedance selection is tappings from the transformer, and the either tappings from the transformer or a combination of tappings from the transformer and resistive elements inside the instrument. And even the power range selection is again completely resistive as well. The instrument uses a diode bridge to actually measure and deliver energy to the meter circuit. Very basic instrument. Now this instrument was used in when I was working as a radio technician for the New Zealand Post Office. Specifically the receiver audio output would be preset to an appropriate level. That level would be put into an interface card and either fed to the transmitter if it was a standalone repeater, or fed to the transmitter and into a transmission network if the repeater was part of a multi-site repeater network. Now one day I'll perhaps be able to gather up some of the photographs of the sites I've worked on, and with luck I might even be able to find some engineering input of the Hatfield 42332 card, which was used as the interface between the receiver and transmitter on most of the New Zealand Post Office sites throughout my time. And there was a multi-port amplifier too. I'm just can't remember the designated name or number of that multi-port amplifier. It might even also, if I'm successful, come up with the transmission plan that was used to get the audio levels throughout this network. But anyway, I have two of these things on my bench here. There's one of them and the other one's up here. So I'm in the process, I think, of I'll give this one away. Hopefully somebody can get some use out of it. Its performance roughly follows the performance of the human ear. The human ear is not particularly good at low frequencies, down below 50 Hertz, 100 Hertz maybe, and the performance above, say, 16 to 20 kilohertz also falls away. And somewhere in here, and this has just been downloaded from the internet, you can get a copy yourself by searching for Marconi TF893. Yeah, there's the typical frequency characteristic of the instrument. I'm not sure if this will show up on camera, but you can download it if you want. Performance falls off at the low end and also falls off at the top end. Here's a simple diagrammatic representation of how the instrument works with a transformer input, resistive selection for impedance, as well as meter range, and a diode bridge for measurement. Anyway, these things stood us in good stead. A basic instrument, built like a proverbial brick, whatever. Took a bit of a caning in the field. What can you say about them? She's an instrument to stir the memory. But unless you're playing around with audio levels in the vicinity of 1 milliwatt to 10 watts, they actually have very little value. There's other ways to measure that kind of thing now. Anyway, we'll give this one away, I think. It'll probably go to the radio amateurs. Might even end up in their museum. Well, I had a bit of a dig through my manuals, textbooks of electrical engineering and all manner of things. In among this lot, found some Tate service manuals. 345 UHF base station receiver, Tate 346 UHF FM base station transmitter. Bits and pieces here, frequency counters, and lo and behold, the AF power meter manual. Fantastic, look at that. Now, I'm not sure if this will show up on camera, but this manual is complete with a schedule of parts, operation instructions, maintenance. Goodness gracious me, there's even a guarantee claim. There's a photograph of what the thing looks like on the inside. Look at that. This equipment's that old, of course, that you wouldn't have much of an expectation to find a service manual for the thing. Interior parts. Spares ordering schedule. Ooh, schematic diagram. There we go, there's the complete schematic. Okay, well, we'll have to make sure that that service manual actually goes with the instrument itself.